Now we're going to, once we have the line up, we're going to then create the inequality, which has more than the points on this line as a solution. It has an area that is a solution. There's more than just a few points that will fall on the lines that will satisfy this condition. So this reads as 8x plus 5y less than or equal to 40. And we want to figure out where we shade. Now we always shade away from the solution area. All right, we don't shade the solution area, we shade away. So we have to determine where that solution area is. So the easiest thing to do, if you can test a point, and you can test any point to see if it works for this inequality, meaning that it makes it true. It makes this side less than this side. So we're going to test a point. The easiest point to test is the point 0, 0. Right here, 0, 0. And it's just because the math's easy, basically, is why we picked 0, 0. Now, here's our inequality. X plus 5y less than or equal to 40. If we test the point 0, 0, that means that we stick in 0 for x and y, and we stick in 0 for y. And what that does is it gives us 0 plus 0 less than or equal to 40. Is 0 less than or equal to 40? Well, it's definitely less than 40, so it works. All right, it works. And what does that? It means that this point, 0, 0, is in the area of the solution for this. It makes this statement true. So any point over here will work. So what we do is we want to shade away. We want to shade away from the solution side. So what we do is we shade this side of the inequality. Now we have the second equation, inequality, which is 10x plus 3y less than or equal to 30. If we stick zeros in for those, and we use the point 0, 0 to test, and we stick in the zeros here, we end up 0 less than or equal to 30 on this side. And that's true. So 0, 0 works for that equation as well, which is the black line here. And so what we've done is we've shaded this area initially for the first equation, and now we're going to shade for this equation, for the black line, we're going to shade on this side. Got a little bit of an overlap here, and so we have that much shaded. Now when we bring the graph of y is greater than or equal to 2, we simply start with a straight line. Y is equal to 2. This is the line y is equal to 2. Now, if y has got to be greater than or equal to 2, then you don't even have to test a point. You can, but logic says that if y is got to be greater than or equal to 2, then it has to be anything above the line is going to be where y is greater than 2. So the solution for this is above the line. This actual solution is above the line. Y is always greater than 2 above the black line. So since we're shading away from the solution set, we shade here. And what we've basically created is a feasible region that is not shaded in here. So if you want it to, I don't know, if we want it to just sort of outline that, we have this area in here. And these points of intersection that you see here, these vertices where of the shaded area, which tend to be points of intersection, are very important, which we'll talk about next video.